So, we are discussing the design of a fuzzy logic controller. In the last lecture, we have learned how the rule base, which is an essential part of a fuzzy system, has been developed. So, today we will discuss about the other there are other modules. So, today we will discuss other modules, namely these three modules. So, fuzzy inference engine, Fabrication module and Deviation module. Now, so first we will discuss the Fabrication module, because the input, it will take the data that is required to control the system, and the Fabrication module will produce an output which will be used by the fuzzy inference engine. So, we should learn Fabrication module first, then we will be able to discuss about the fuzzy inference engine. Fuzzy inference engine will consult with the fuzzy rule base and then produce an output, that is the fuzzy output. So, fuzzy output will be the input to the defabrication module, that is the final module in the fuzzy logic controller, and we will discuss then the fuzzy logic defabrication module. Defabrication module will gives the output, that output will be used as a Crisp value and then helpful for the controlling some application. So, this is the task that we are going to learn today, Fabrication module followed by the fuzzy inference engine and then defabrication module, and we will follow the Mamdani approach, because we are discussing Mamdani approach first. Now, first we will discuss about the fabrication of input. So, fabrication input, as we have already discussed, that for a given input, that is usually the Crisp input, and then how this Crisp input can be converted to the fuzzy input. Now, the system that we are discussing in this application is a mobile robot, and we have already mentioned that mobile robot has the two input, namely the distance and then the angular direction of a moving object. So, here let us consider for an example, at any instant the distance from the robot to a moving object as in an input, and this is the input, and angular direction, that means in which angle making an object moving towards the robot, and let it be theta, and theta is a value at the current time instant is 30 degree. So, these are the two input, then these are the two input will be given to the controller as a Crisp input. So, fuzzy controller will transfer these input into the fuzzy output. So, we will discuss how the these two input can be converted to the fuzzy input. Now, so in order to understand how this Crisp input can be converted to the fuzzy input, we can take the care about the membership function for each fuzzy linguistic state that we have already discussed. So far the fuzzification of the system is concerned, and there we can recall we have discussed three membership functions, rather two for the input and one for the output. For the input, we have discussed about that distance as a four fuzzy linguistic, namely very near, near, far and very far. And similarly, for the angular direction, we have considered 5 fuzzy linguistic: left, ahead, ahead right and then right. So, we have to take the fuzzy input in terms of these fuzzy linguistics. Now, for an example here, as we have considered, d is 1.04, this is the Crisp input, so far the distance is concerned, and so far the fuzzification is concerned. So, d 1.04 is this is the element, and this element has the two fuzzy states, namely near and far, because it cover both the things. So, this means that the Crisp input 1.04 as the distance can be considered fuzzily in terms of two fuzzy values, the fuzzy near and then fuzzy far. So, distance 1.04 has the fuzzy membership belongs to the fuzzy state NR, and 1.04 also is a fuzzy member belongs to the fuzzy state Fr, but they belongs to the two fuzzy sets Nr and Fr with certain degree of membership values. So, we have to calculate the degree of membership values for these two elements which belongs to Nr and Fr. Now, first 1.04 being the distance, and if it belongs to fuzzy state Nr, then the membership value can be decided by this. That means, this is the membership value is this one. So, we have to calculate what is the value this one. Similarly, if we consider the Fr fuzzy state, distance also belongs to the Fr fuzzy state, then so this is the membership value this one. So, 1.04 Cripps input belongs to two fuzzy state Nr and Fr having the two different membership values, for Nr this one and for Fr this one, and we have to calculate these two values first. Likewise, angular rotation that we have considered in this example, that theta is 30 degree. So, theta is 30 degree means this one 30 degree. 30 degree being the Cripps input has the two fuzzy states, one is ahead and then ahead right. So, if it belongs to ahead, then the membership value can be computed this one. So, this is the value that we have to know. Similarly, if it belongs to ahead right, then it has a membership value the same here in this particular case only. So, these two membership value needs to be calculated, and then finally, output will be considered, that will be discussed later on. Now, let us see how the input values, the fuzzy values with their membership can be calculated. So, this can be calculated okay, for example. So, okay, fine. So, we can understand that d distance 1.04 can be called either Nr or Fr, that means they belongs to the two fuzzy state with different membership values. Similarly, the angular orientation theta 30 degree can be called as either ahead or ahead right with the different membership values, and we are in the process of calculating the membership values of there. So, here is an example how the membership values for the two inputs, one is distance and another is angular orientation, can be calculated. So, it is the calculation shows that the membership values for the distance x equals to 1.04 which belongs to the fuzzy state Nr can be calculated as this one. Similarly, the membership values for the input x which belongs to the fuzzy state Fr can be calculated this one. Likewise, the membership values for the other input y equals to 30 degree which belongs to the fuzzy state AA can be calculated as like this, and AR can be calculated like this. Now, question that is how this calculation obtained. So, this calculation can be obtained using similarity of triangle, and it is very straightforward calculation. So, let us see how this calculation can be calculated here. So, idea of this calculation is given like this. So, it basically follows the principle of similarity. Now, principle of similarity means if we consider, so this is the one triangle and this is the another triangle. So, these two triangles are similar triangle. If they are similar, then we can write x by y is equals to delta 1 if this is the delta 1 and if delta 2. So, it is a formula that we have from the principle of similarity of two triangles, we can follow this one. Now, the same logic can be applied to calculate the different membership values. For example, here if we consider distance 1.04 as the input and we want to calculate so this membership value Nr, right. So, we can consider this is the one triangle and the entire triangle, they are similar triangle. Now, if we consider these things, then for this it is basically this value is 1.5 minus 1.04 and divided by then this value basically 1.5 minus 0.8, and then if we consider this is basically x and this is the 1. So, it is x by 1 is equals to 1.5 minus 1.0 this one. So, this way x will be calculated this one. So, x means it is basically this is the x, okay, it is calculated this one. So, this value is basically 0.6571 in this case. Similarly, for the angular orientation theta we can calculate likewise. So, it can be calculated like this. Now, okay, fine, I just forgot one thing more. So, this is for near. Similarly, for FR also we can calculate. So, if we calculate the FR, then we should take this is the triangle similar to this is the another triangle. So, using these two triangle similarity we will be calculate this value. So, this value can be calculated as a 0.333 something that we have already learned about it. So, this is the way that the value can be calculated, and the same approach can be extended to calculate the membership values for other input theta equals to 30 degree. We can follow this is the one similar triangle and this is the one similar triangle to calculate this is the value, and if we consider for the AR we have to consider this similar triangle then this similar triangle, so that we can calculate this one. So, both way it can be calculated and the result can be obtained. So, the result that can be obtained is shown here. So, the result that can be obtained that can be obtained easily and then can be used for the next what is called the next step. Now, our next step. So, what we have learned is the Fabrication module given an input. So, for x equals to 1.04 as the creeps and theta equals to 30 degree the two input, and Fabrication module will give you the different mu nr x, mu fr x, similarly mu aa so theta, and then mu ar theta. So, these are the value, that means 1.04 this is the one fuzzy element, 1.04 is the fuzzy state, and similarly 30 degree is the fuzzy state having the membership value, 30 degree is the fuzzy state having the membership value. So, all these values will be used as an input to the fuzzy inference engine. So, these values will be used to the fuzzy inference engine, and then fuzzy inference will use these values and consult the fuzzy rule base and then produce an output. This is called the fuzzy output. Now, we will discuss how the fuzzy inference engine take care these values and consult the fuzzy rule base and produce a fuzzy output. That is basically the idea about fuzzy inference engine, and we will discuss how the fuzzy inference engine can be implemented using Mamdani approach. So, the idea is that fuzzy rule base is there, that we have already learned, and in our fuzzy rule base in the context of current mobile robot example, we know that 20 rules are there. All the rules are depicted here in the form of a rule matrix. So, out of these 20 rules we have to decide, particularly fuzzy inference engine will decide which are the rules are exactly useful so far the current input is concerned. That means, out of 20 rules, all rules may not be applicable in the current context. So, fuzzy inference engine will take a calculation which basically try to see out of these 20 rules at least how many subset of rules those are basically related and can be considered to calculate the fuzzy output. So, that is the objective of this fuzzy inference engine. So, fuzzy rules, those are the 20 rules we have discussed about it, that can be considered here. Now, one thing we can understand here, that in the current context again we see out of these 4 linguistic only near and far are the important. Similarly, out of the 5 linguistic states related to the angular orientation, only these are important. Now, if we consider then, so then intersection of these things means only these 4 rules are basically important. That means, if x is nr and y is aa, then deviation is right, one rule. If x is nr and y is ar, then deviation is aa, another rule. If x is fr and then y is aa, then angular deviation is theta ar, and if x is fr and then y is ar, this one. So, out of 20 rules in this particular context, depending on the states so far the distance and then angular orientation is concerned, only 4 rules are irrelevant. So, these 4 rules we can display here, list here. So, these are the 4 rules that we have just now identified. If distance is nr and angle is a, then deviation is RT and so on. So, these are the basically 4 rules that is relevant in the context of current input. So, at any instant fuzzy logic controller will receive this input, fuzzify it, these are the fuzzified values, and based on this fuzzify it basically decide what are the rules that can be fireable, and then it will see that these are the most relevant or significant rule so far the decision of output is concerned. So, fuzzy inference engine will take care about it, take an input and then select the subset of rules which are relevant, and then it does more. In fact, it basically out of all the rules it can take care all the rules and then decide the output, but to be an accurate and then more efficient, it will try to find some rules which is already selected or shortlisted here, so that it can be more accurate, and that is why out of these 4 rules again it apply to rank them and then decide which are the rules are more strong. So, it basically Mamdani approach is the next step in the inference engine is to basically compute the rule strength of the selected rules. Now, how the rule strength can be computed, I have given an idea, I would like to give an idea about it. So, it basically calculates, is very simple approach to calculate the strength of each rule, and this is denoted by called alpha values. So, if R1, R2, R3 and R4 are the 4 rules, the alpha value can be calculated like this. It basically take the minimum of the fuzzy membership values for the input. Now, in the context of first rule, the 2 membership values related to the fuzzy state nr and the fuzzy state AA having x element are the input, and then we have already known the membership values of this. So, it will take the minimum of the 2 membership values at the rule strength. Now, in the current context, the mu nrx can be calculated as this one and mu ay also calculated as 0.33. So, it taking the mean, so it gives the rule strength of the first rule. Likewise, rule strength for the second rule can be calculated this one and this one and this one, is taking the mean of the different membership values belongs to the different states corresponding to particular input. Now, out of these 4 rules, then it selects, right, some rules which are basically based on some threshold value. Now, if we take the threshold value is 0.300, then all rules will be selected. Now, if we select on the other hand the rule strength is 0.3400, then only this rule and this rule will be selected. So, it depends on the threshold value, and the threshold value will be decided by the fuzzy engineer from his own experience or using trial and error method anyway. So, some threshold value is required in order to select again from the shortlisted rules. So, fuzzy inference engine take a value of a threshold value, and then based on this threshold value it will compute the rule strength, and then based on the threshold value from the rule strength it select the stronger rule which basically above the threshold value. Now, if we consider for an example say rule strength the threshold value is 0.3400, then the rule that will be selected shortlisted is there. So, if we consider threshold value is 0.3400, then this rule will be ignored, this rule will be ignored, only this rule will be considered. So, out of the 20 rules, because of the relevancy we have selected 4 rules, and then again by means of rule strength computation we have shortlisted from the list of selected rules 2 rules only. So, these 2 rules will be used to calculate the fuzzy output. So, this is the task up to the fuzzy inference engine. Fuzzy inference engine consult the rule base for a given input and then select the rules according to the relevancy, and from the relevant rules it again compute the rule strength and based on the rule strength computation and threshold value we select the final list final rules. Those are basically will be used to calculate the input output of the fuzzy system. Now, our next task. So, fuzzy inference engine basically take the input fuzzy input and then produce the selected rules. These selected rules basically gives us the output. So, we can say the fuzzy inference return the selected rule the strong rules, and then from the strong rule we can have the fuzzy output. Now, we will discuss about how the fuzzy output and corresponding defuzzification of this output is there. So, this is the final stage of the fuzzy logic controller, defuzzification of the output, and we will discuss this defuzzification method in the next few slides. Now, so the idea is that fuzzy inference engine returns some rules, those are more appropriate so far the decision is concerned corresponding to some input. Now, so these rules are basically essentially the output. For an example, so suppose is just any two rules are like this. So, this is the one rule and these are two rules. So, output of this rule is basically C1, that is the output, and output of this rule is C1, C2. Now, so if we combine the two outputs, then the resultant output C is basically union of the two outputs C1 and C2. That is the idea that is followed in Mamdani approach there. If there are more rules other than two rules, say there are n rules, then it will take the union of n output that is there. And so, output for the system, it is basically in a fuzzy way, it is the fuzzy output. So, it is like this. Now, in our current example, so that there are two rules we have selected. If x is nr and y is aa, then delta is aa, that kind of things are we have considered. So, the output is there. Now, we will see exactly how given such a rules the output can be calculated. Okay, we will although give an example of graphical method, but the same thing can be done in a mathematical way, which we have already discussed while we are discussing about defuzzification concept using centroid method or maxima method or weighted minima method, whatever it is there. So, we will consider, so any method can be applied here. Now, let us see how the output of a fuzzy system based on the different rule can be computed. Now, suppose this is the rule 1, this is the rule 1 and then graphical representation of the rule 1. It basically says that if mu a1 for an input and if this is the fuzzy state, and if mu b1 for an input and this is the fuzzy state, and this is basically the output of the fuzzy state. So, for a particular values of input, so it basically take the this is the basically input and for another input is there. So, two input are like S1 and S2, and then these are the basically rule state these are membership values for the first input and this is the membership for the first input that we have already calculated. Now, if we draw a line joining this thing and parallel to the horizontal axis, then it cut this one, and if we like this and this one. Now, so these are the basically output. So far the input is concerned, so this is the output, and so far the input is concerned, this is the output. So, Mamdani approach said that out of the two output you take the minimum of the two. So, these are the two output correspond the input this one and this one, and we taking the minimum of this. So, this is the resultant output. So, the rule 1 is concerned. If this is the rule 1, so for the rule 1 this is the output. Now, similarly for the rule 2, again these are the input corresponding to the fuzzy state and this is another input for the another fuzzy state, and if we take the minimum of these two, then this is the minimum there. So, this basically the output C1 and this basically the output C2. Now, so if we plot both the output onto the same graph, the resultant output will look like this, which is shown here. So, this is the resultant output. Now, the defuzzification of these output can be obtained either using COG method or COS method, and we will be able to obtain the crisp output from this one. Now, so now let us see how in the context of mobile robot we can have the data here. So, there are we will consider the 4 rules suppose, right. In the last example that we have considered only 2 rules, we will consider the 4 rules that we have shortlisted there, and then how the 4 rules. For an example, 2 rules can be considered, then it will be more simple. I want to give an example with the 4 rules that have been shortlisted based on the relevancy R1, R2, R3 and R4. Now, let us see how the output can be calculated. Now, here this is the basically input so far the distance is concerned, and this is the input so far the angular orientation is concerned, and this is the output regarding the orientation here RT and A. Now, so if this is the distance x and it will cut the value there for this is for the NR, and this is for NR for the rule 1, and this is for the NR for the rule 2, and this is basically distance 1.0 for the rule 3, and this is distance NR for the rule 4. So, it is basically NR and this is basically FR, this graph is for FR, this is for FR and this is for FR, and this is the angle of orientation like this. Now, again, so rule 1, if we fire with x equals to 1.04, right, it will basically cut this one and take the value. So, this is the membership output that is for the rule. Now, if we take another input theta, then it basically cuts here and this one. So, taking the minimum. So, this is basically the value of the output for the rule R1. Similarly, value of the output for the R2 can be obtained as this one. So, for the rule 3 is concerned, value of the output will be this one, and so for the rule 4 is concerned, value of the output will be this one. So, for 4 rules we got 4 outputs C1, C2, C3 and C4. Now, from these 4 output we can calculate the fuzzy. So, from these 4 output fuzzy output we can calculate the crisp output value. That crisp output value can be calculated using COG method or COS method. If we follow COS method, for example, we take this area and the middle value, take this area and middle value, take this area and middle value, take this area and middle value, and use the equation that x1 into a1, if it is x1 it is a1 the area, if it is x2 and a2 and x3 a3 and x4 a4, and then formula is x1 a1 plus x2 a2 plus dot 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 divided by a1 plus a2 plus a3 a4. So, this will give you the output, so delta value. So, this way it can be calculated. Now, let us see what is the results that we can have based on the calculation, say COG method. In case of COG method, all the output can be plotted on the same graph, this can be plotted on the same graph, and then from the resultant graph we can apply the COG method calculation, so that the fuzzy output can be calculated. Now, I can give an example here. For example, if we plot the 4 different outputs into the same graph, the graph will look like this. So, it is basically this is the graph, then this graph, then this, then this, then this, then this. So, this is the output graph actually for the 4 rules related to the input x and theta. X is 1.04, theta is 30 degree. Now, the value can be calculated using COG method, is the segment and whatever the method it is there, we will be able to calculate it. That calculation is little bit cumbersome here. So, if it is the calculation is too much difficult for the COG method, then we can follow COS method or some weighted minimum method, whatever it is there. Now, using the COG method for the same thing, the result that can be calculated is shown here, and that is basically the defuzzification. So, fuzzy outputs needs to be defuzzified and the crisp value has to be determined for the output to be taken in this current context. In the current context, so this is the input here, this is the input and this is another input, and then output is basically delta regarding that in which direction it should move. So, that basically obtained by the fuzzy output, and then corresponding the crisp value, if we follow, it can be obtained the result. Now, so far the current example is concerned, the result that can be obtained using some COG method. Here we have applied the COG method like, and it can be calculated as the this one 19.59 or 20 degree. So, this means that the robot that has at the current instant seeing an object, these are seeing an object, okay. The current instant seeing an object, right, it will basically move to the right, a positive, because this is a positive value, to the right as a angle with respect to O3, the 20 degree, and that is the angle. So, that fuzzy logic controller will take a decision about that, it has to deviate from its state path towards the right by 20 degree. So, this output then can be given to the process controller, and process controller will take this input, and then okay, accordingly controller will move change the path of the robot. So, this is one example that we have discussed about it. So, far the fuzzy logic controller is concerned, and we will discuss next another logic controller design, that is Takage-Sugano approach, and in our next lecture we will follow the Takage-Sugano approach in this regard. Thank you.